Okay, so in talking about outliers, you're going to see that there's a lot of discussion that's been had about outliers for decades now as to which way is the right way to do it. And so, what I have found as a dissertation coach and a methodologist at several schools is that it really depends on your chair or your project advisor as to which way they want you to do it. But I want you to have a good overview of what this means and so that you can defend it yourself as to what the right way is to do it. So let's first just do the easy way. Let's go to analyze descriptive statistics, and we're going to go into explore. And then I just want to, I'll hit reset. I want to do one at a time. The reason for this, if we do too many, it's going to get out of control quickly. So we're just going to do one variable, leave everything as is, the way SPSS has it pre-programmed, and hit OK. All right. Even though we put that in the dependent variable, by the way, it doesn't matter if that's your dependent variable or not. All we're looking for is one variable to see if there are outliers. Okay, so here we have a big list of outliers for this. Now there's some rule of thumbs. There's a lot of rule of thumbs. You'll notice in the Hair et al. Book, he has rules of thumb in most of his chapters. Or they do in most of the chapters. And so there's the same thing happens as we move along with SPSS. So you have the circles or dots and you have the asterisks. So I want to give you some idea of what that means and some of the argument behind this. So the circles or dots, those mean that the outlier is based on a multiplier, an interquartile range multiplier of 1.5. Well, what does that mean? I'll show you that in just a minute. The asterisk means it's based on an interquartile range multiplier of 3.0. Now, sadly, neither one, not most people, I don't know if most people are not. Sadly, there is argument that neither one is accurate. And yet here it is in SPSS. So I want to give you the support for this and then give you options. Basically, again, we have the circles and then we have the asterisks. So how do we know what is what and what that looks like? Let me show you some of the evidence. Okay, so you've probably heard of Tukey. John Tukey did a lot of work with statistics. This is his 1977 book, and this is actually information directly from his book where he talks about what an outlier is. In this, he says the rule of thumb. So that concept of rule of thumb has gone way back. Says that an outlier is any value that is beyond 1.5 times the interquartile range above the third quartile or below the first quartile. Well, that still sounds confusing. So I want to show you what the quartile looks like, and then we'll talk a little bit more about this 1.5 number. So this is where it starts in 1977, is that Tukey is introducing this concept of an outlier methodology. Okay, so I want to go back to analyze descriptive statistics and explore. And then we have our variables sitting in the dependent variable list. This time, instead of just hitting OK, I want to go into statistics. Now, I want to uncheck descriptives and then hit continue. Oh, I actually want outliers and percentiles checked, so make sure you have that. And then I want to go into plots and uncheck stem and leaf and hit histogram. And then hit OK. Now, what this is going to do is give us a little bit of a different view. So in the last one, we could see the outliers, but here we want to see what the percentiles are. So specifically the 25th and the 75th percentile. Now, this is a basic, the responses could have been anything between a 1 and 5. And so we're seeing that 25%, the 25th percentile is around 5, and the 75th percentile is around 6. So if we look at the histogram, it looks like this. So most of the responses are in that 5 and 6 range. Now we can still see here are our outliers. Okay, so let's go a little bit further. Okay, so I have a couple more articles to show you. This one's from 1986. You'll notice that Tukey is one of the authors here, so he's still, 9 years later, still working on Outliers. And I think this is helpful. It also shows you a couple more authors that have joined him in this effort of research. So Hoagland and I don't know, Igelwicks maybe are the other two authors. In this one, they actually name his concept, the outlier labeling rule. So that's really all this article does, is that he's calling it the outlier labeling rule. And then in the other article, you'll notice that Hoagland and Igelwicks are still on here. Tukey is no longer on here. But in this one, they're talking about this 1.5 rule. So where the circle comes in, if we go back to SPSS, the circle is calculating it at 1.5. And then SPSS also has this addition to calculate it at a multiplier of 3. So as the easy way out, I usually just look at the asterisks. And I don't look at these other two. Just look at the asterisks. Those would be your outliers. That article basically, though, is telling us that the right answer is 2.2. So 3 is too much, 1.5 is too little, 2.2 is the answer. Why SPSS hasn't changed this to make it right, I don't know. But that's where we're at with it. So you could just ignore these 6 outliers. We'll look at these 3 as outliers and then move forward. So that's one rule of thumb. Probably the right rule of thumb, or the closer to be right rule of thumb when we look at this, is just looking at the asterisks. To me, that's the easiest. That's typically what I personally do. There are other options for this, and I will show you that as well. So just a moment. Okay, so now we're going to do the Z-score approach. So I want to go to Analyze, Descriptive Statistics, and Descriptives. And this one, you can put all of your variables in at one time. That's okay. So we're going to put them all in. To do that, make sure one is highlighted at the top. Go down, hit Shift on your keyboard and the bottom variable, and then move them over. Then click this button, Save Standardized Values as Variables. And let's see. Okay, I think that's all we need to do. Let's hit OK. And what this does for you is it actually adds new variables to the data set. So it didn't change anything. Let's go to variable view. It didn't change anything with these. But what it did is it took and added more for each and every single variable. And it's using an average. The Z-score is actually, let me go back to my notes here. The Z-score is actually a way to standardize all of the data at one time. And we're looking for the mean of the actual value of the data. So you'll notice too, when we go to variable view, or data view rather, it's different. So let's look at our ELI1P. Number 1 starts with a 4. And then if I come over here to, let's find it, ELI1P, it's the very first one. Here we go. It's a -1. So it's standardizing the data. Tells us the number of standard deviations a value is away from the mean of a given distribution. In other words, it's taking a look at everything in here and then calculates that distribution and then tells you how far away it is from that. I hope I'm explaining that right. So anyway, what that does for us is it gives us another view to look for outliers. So if we go back to Analyze, Descriptive Statistics, and Explore, and I'm going to hit Reset. And I just want to bring this one over because that's what we've been looking at, and we hit OK. We can see now we have one outlier, or actually, no, we still have three outliers. We still have three outliers using the asterisk method. So again, it's one of those where we can try several things and then decide what we need to do with it. This is why I think knowing your data is is the safer bet to go. So if I looked at EL1P and I looked at everything from 1 to 6, and I decide, well, how many are in the ones? We have 3 there. We have quite a few here. It says 138 there. We just get more comfortable with the data, then we might be able to see the outlier ourselves. Now there is another method, so let me show you that one real quick. Okay, so I want to spend just a few more minutes on this z-score and outliers. So still focusing on the first variable ELI1P. I wanted to show you, if we use a histogram to look at the bell curve, we can see that there's a bell curve there. It's, the data starts, you can see here that the mean is 5.05, the standard deviation is 1.037. So we're starting at a 5. That's where the peak in our bell curve should be, because that's the mean. That's the center of it. And then with our z-scores, we're trying to figure out how far, either to the left or the right, that the other scores are in relation to the mean. So I hope that helps to clear that up. Now, along with this, if you remember earlier, we did a test to look at the percentiles. And so with that, we can see the 25th percentile is a 5. In this case, the 50th is at a 5 too, because that's our mean. And then the 75th percentiles at a 6, which in this case is the actual top of the data set. So hopefully that's helpful. We can see the bell curve is there. And then our average or the mean actually is 5.05. That's where most of the data is coming in at 5 and 6 right there. And then we have some of this data over here to the left. So maybe, we're thinking there could be some outliers. If you remember, we had 3 showing up. So I want to show you now how to do this. Going back to Excel, just to verify one more time if this is accurate. Okay, so we do have a formula for the z-score, basically x, meaning that's our actual value for that variable, minus the mean score divided by the standard deviation. So I'll show you how that looks in Excel. I've added 3 new columns here. This is focusing on the ELI1P score. And with that, I added our mean and standard deviation that we received from the actual SPSS output. That's helpful. We can actually calculate that here too, but 5.05 and 1.037 is what we saw in the SPSS output for our here we go. Let's go back up to our histogram. Actually, I can show you here. I have it in the slide. Here we go. So we don't have to waste much more time on it. But here we have the mean is 5.05. The standard deviation is 1.037. So I've put that in here. 5.05, 1.037. And then we're just going to calculate it. So we're taking the value from ELI1P, subtract the average or the mean, and then you are dividing it by your standard deviation. So again, this is way more than what you need to know, but I want you to see and get comfortable with this. And then the question becomes, okay, now we have a z-score. What do we want to do with it? Some people say that 2 plus or minus 2 is not the correct answer. Some people say 3 is the correct answer, and some people say 4 is the correct answer. So in this case, let's go with 4. We are seeing 3 different variables here, which is consistent with what we were seeing before when we looked at the data, and we could see that there were 4 items trying to show as outliers. So we have the option now. We could remove those or leave them in. With a data set this size, we'd have to do this for each one. So it's something that we can think about. In this case, I want to leave it where it is for the moment. Okay, so we're going to do one more test just to go back. We're going to look at descriptive statistics and explore. Um, let's reset this. We've got ELI1P there. In the plots, I actually want to do the histogram and the stem and leaf and the normality. Hit continue. I want to click on outliers. I could click percentiles too. Hit continue and hit OK. All right, so this is going to give us a good summary of what we've been talking about. There's your percentiles again. You can see the 25th percentile, the 75th percentile. You can also see here's our histogram that we had the bell curve overlaid on it earlier. There's your mean standard deviation. This is a QQ plot. We'll talk about that later. But mainly what we're looking for here are these three outliers to decide what to do with those three outliers. We go back into SPSS. You remember that we had this organized, we sorted it here. And that's why now it's 1, 2, 3. These are pretty close to 4, so technically you could remove them. Now, there's all sorts of argument. Do you remove it? Do you not remove it? So for the sake of the assignment, you might note that you could remove these 3. I wouldn't remove them right now, but you could remove these 3. You could also go on into these other ones, sort it. Let's see. Sort it. And you can see, well, there's 3 more there. You also have to look at the bottom to see if there's 3 on the other side or if there are any outliers on the other side and there's not. And then we could come in here, look at this. So again, you've got 3/4. So that one might be worth investigating further to understand. But sometimes outliers are part of the natural data. You know, again, it goes back to understanding your data and why that data looks like that. So for now, I'm saying don't remove anything, but actually you could record that here you have 3/4 and you have quite a few over 3. So the question then becomes, do we remove them if it's over 3? Do we remove them if it's over 4? Over 4, you're probably safer. But again, it just truly depends. I would get to know your data, and that's why I like to dig around more in SPSS, really get to know your data, understand where it came from, what the numbers mean, what the options were for these numbers, and that helps. So that's all I have for outliers today. I'm sure that was confusing. So there's no reason, I understand why I had so many questions about this, but anyway, I hope that's helpful. Have a good evening. Thank you.